Asteroids, those rocky celestial bodies that orbit the Sun, have long fascinated scientists and astronomers. These remnants from the early solar system hold valuable resources and offer intriguing possibilities for space exploration. Now, a group of visionaries has proposed the idea of transforming an asteroid into a fully functioning space station, opening up a new frontier for human habitation beyond Earth. The first step in our plan to convert an asteroid into our space station, of course, involves identifying a suitable asteroid for the transformation. Extensive research and analysis are required to find an asteroid with the right composition, size, and orbital characteristics. Ideally, the chosen asteroid should have ample resources, such as water and minerals, to sustain human life and support various activities. After a thorough selection process, Asteroid has been chosen as a strong candidate. This S-type asteroid has an entire class of asteroids named after it. Asteroid measures about 4.8 kilometers in diameter and even has its own moon, a 1 kilometer diameter asteroid that orbits closely around it. While it may not be the closest potential asteroid, its nearest approach is approximately 80 times the distance to the moon. Nonetheless, its orbit is stable within the Goldilocks zone of our solar system, which would help maintain a consistent internal temperature for the habitat it would eventually become. By the way, in case you're not aware, the Goldilocks zone refers to the habitable region around a star, where conditions are neither too hot nor too cold for liquid water to exist on the surface of surrounding planets. Imagine if Earth were in Pluto's position. The Sun would appear tiny, about the size of a pea, and Earth's oceans and a significant portion of its atmosphere would freeze. On the contrary, if Earth occupied Mercury's place, it would be excessively close to the Sun, causing its water to evaporate into a steamy atmosphere. Earth's current distance from the Sun is just right for water to remain in a liquid state. This optimal distance is known as the habitable zone, or the Goldilocks zone. Now, returning to our main topic for today, what type of habitat should this asteroid be transformed into? Scientists have considered 4 common designs: the dumbbell, sphere, cylinder, and torus. One of the most crucial factors to consider is gravity, or artificial gravity, generated by centripetal force. We must take into account the adverse effects of prolonged exposure to low gravity, which necessitates the use of some artificial means to stimulate it. But to get centripetal force, the station has to rotate. Asteroid already has a slight rotation, but part of creating a space habitat would include spinning the asteroid itself up to a reasonable rotational speed that could accurately mimic the gravity a person would feel on Earth. Scientists also consider numerous other factors when selecting a specific type of station, including the forces it would exert on its construction materials, the amount of material needed for the outer shell to provide protection from radiation and micrometeorites, and the extent of interior living space. Eventually, the torus design is chosen as the optimal habitat type, and the focus shifts to calculations regarding the overall station mass, how to support the inner wall with substantial columns, and how to allocate floor space. These aspects are all crucial. But how exactly would we construct such a colossal structure? The solution lies in self-replicating robots. Once the captured asteroid is in position, the true work begins. Transforming the asteroid into a habitable environment suitable for human habitation involves constructing living quarters, research facilities, communication systems, and life support systems. Advanced technologies like 3D printing and robotics will play a pivotal role in this phase. One of the significant advantages of using an asteroid as a space station is its potential for resource utilization. Asteroids are known to contain valuable minerals, metals, and water. These resources can be extracted and processed on-site, reducing the reliance on resupply missions from Earth. This self-sustainability is essential for long-term space exploration and colonization. While the concept of converting an asteroid into a space station is undeniably ambitious, it is not without its technical challenges. The engineering accomplishments needed to capture, maneuver, and modify an asteroid are immense. From developing advanced propulsion systems to creating self-sustaining life support systems, numerous technological obstacles must be surmounted to realize this vision. Another substantial challenge is the cost associated with such an endeavor. Establishing a space station on an asteroid would demand significant financial and temporal investment, turning it into a project that would likely require international cooperation and backing from both public and private sectors. The program is estimated to cost only $4.1 billion, far less than the $93 billion NASA plans to allocate for the Apollo program. The outcome would be a space habitat that provides 1 billion square meters of land that did not previously exist. This results in a total cost of $4.10 per square meter to create land in space. Possibly even more impressive is the timeline. Scientists estimate that the entire construction project could be complete in as little as 12 years. However, it will still take longer to fill the habitat with air and water and begin regulating its temperature. Nonetheless, this is a relatively short timeline for such an ambitious project. These costs and timelines also fall within the personal wealth levels of billionaires who have already shown an interest in space exploration. We're looking at you, Jeff and Elon. As with any ambitious scientific project, ethical considerations must be taken into account. The potential impact on the environment and the potential risks associated with altering celestial bodies should be thoroughly evaluated. It is crucial to ensure that the benefits of such a venture outweigh any potential harm to the asteroid itself or the broader cosmos. The concept of transforming an asteroid into a space station is a creative and forward-thinking idea that has the potential to revolutionize space exploration and colonization. This colossal project holds immense promise in advancing human presence beyond Earth. While there are numerous technological and scientific challenges to overcome, the potential rewards make this endeavor well worth pursuing. The dream of living among the stars may soon become a reality as we continue to push the boundaries of human achievement. Thank you for joining us on this journey of discovery. If you enjoyed this video, don't forget to hit that like button and subscribe for more interesting content. Until next time, guys.